good day, Algebra. We'll see how this goes. We've come to the last objective of our unit, which is your only PO of the unit. No, I take it back. Actually, your first one was also PO9, writing it in expanded form. And now we've got PO15, which is all these rules put together. Okay. If you look at what's coming up as far as your homework, you can see that you've got negative exponents with multiplying by the same base, negative exponents with distributing with multiplying by the same base. We're combining these, okay? And the good news is that generally it does not matter what order you perform the rules. It's not like the order of operations where there's a specific order that you should be following. Not so here. Okay, you can generally kind of just do them in whatever order you want to, as long as you do them all at some point. Then we'll close with another practice sheet. It runs through every single rule that we've had, starting with CO10, CO11, 12, 13, 14, and then a combination of rules here. So this is essentially everything that we did in the unit, save for PO9, is summarized in this section here. So if you want to make a help sheet, which I highly recommend you do, you really need to look no further than these 5 rules here. Okay, multiplying by the same base. For review, what happens to the coefficients when multiplying by the same base? Jack, what happens to our? This is back to CO10. Okay. What happens to those coefficients when we multiply by the same base? Alex? They are multiplied. Okay, they are multiplied. How about those exponents? Multiplying by the same base. Added. They are added. And the base, Anthony, stays the same. How do you know that you're dealing with this rule, this multiplying by the same base rule? What are you looking for? What's kind of your clue, Beckman? You got the same bases. It's part of it. Kylie? You got the multiplication symbol, right? A sample of what this would look like might be 7x squared times 8x. You've got that multiplication symbol in it. That's how you know you're multiplying by the same base, and this rule is going to apply. Okay? Dividing by the same base. Let's start with how you know that you're using it here. How do you know that you're using dividing by the same base? What's going to be in the expression? Kylie? Division symbol, right? It's going to be a fraction. Okay? Something over itself. What do you do with coefficients when dividing by the same base? Again, you already have this written down on CO11. We're just putting it all in one place for you now. Anthony? Simplified. That's not a very good. There we go. Simplified. How about those exponents? Catherine? Subtracted. And the base, Long John, stays the same. Okay? Our zero exponent, CO12. Obviously, you know you'll be using this rule when you have a zero exponent, right? So the exponent is, you're going to be 0. Okay? That's how you know that you are using this particular rule. What happens to the base? We'll start with this one this time. What happens to the base when I put the power of 0? Joey? It becomes a 1. And only the base becomes a 1 because the coefficients stays the same. This is that one rule where the base is really affected. I mean, it's always affected, but it's visibly affected by the power here. All the other rules, the base kind of stays the same and the powers change. But in this case, that base becomes a 1 and it's the coefficient that stays the same. Negative exponents, obviously you can tell you're using this rule because you'll have a negative exponent. Let's start with the exponent this time. What happens? What's the niche with negative powers?
You add them together.
No, you do not. You get a negative power, Christopher. Moves to other part of fraction. Wherever your negative exponent is, you're going to move it to the other part of the fraction. If it's in your numerator, you move it down. If it's in your denominator, you move it up, other part of fraction. What goes with it, Catherine? The base, okay? Follows exponent. I should also note with the exponent that once you move it, it also becomes positive. Didn't make a long enough line for this here. Okay? When you move that negative power, it does become positive. The base follows the exponent, but other than that, it doesn't change. It stays the same. A negative exponent does not make a base negative. A negative exponent does not make a base negative. And the coefficients for negative powers? Someone new? No? Kylie? Stays the same, or stays put. Stays put's better. I called him like for one of the other ones. Sorry. That's fine. I can only call him one person at a time. Distributing an exponent into parentheses. How do you know that you'll be using this rule? It doesn't say verb. It says variable coefficient, variable base. How do you know you'll be using this rule? Joey! Yes! Parentheses. Okay? Parentheses. When you see parentheses, be thinking the distributive property. And I've got this variable coefficient, variable base. Really, that variable coefficient is, I think, mislabeled. But when you have a coefficient that is part of a base, what happens there? Crinkle. Sure, you can take that one. The exponents are multiplied. Okay? And if you've got a base or a coefficient that doesn't already have a power, what happens then? Catherine? Sure. Right. If you have a base or coefficient that doesn't already have a power, it gets the exponent. And remember, the coefficient is the one that could potentially change then, right? Because if it's a coefficient number, you can multiply it out. Okay? If it's the base without a power, it gets the exponent, because everything inside the parentheses does, but it doesn't change. It stays the same. Okay? And that's pretty much it. All right? If you're looking for what do we need to know to be successful on this test? It's this right here. Okay? Know these 5 rules and you'll be good. Now remember, on your help sheet, you can't put any actual examples. Okay? So you can write how you know you're going to be multiplying by the same base. Okay? But you could not then have this worked out. Right? No, because variables are a big part of what we're doing here. Okay? You can write the rules that we have here, but you can't have any actual worked out examples. Okay? So this can go on a help sheet, right? You can have the rule written out, but you can't have any examples of it being performed. Okay? So, here we go. This is going to be, yep. Okay, so now it's just the scrolling. Now it's Word that's not responding. That's a Microsoft problem. Yeah, still, even with, there we go. All right. Any of these 8 that you want to talk about? Alex. What's that? No? Claire. Which one? The 7th one? 3rd one, second row? So looking at this one here, okay, let's first identify what we have. Do we have any negative powers? No. Do we have any 0 powers? No. Do we have any parentheses? No. Okay, so I see the multiplication symbol, right, which means we are multiplying by the same base, and I see we've got fractions. Okay, what can we do? What do you see that we can do first here? Catherine? How? Okay, so Catherine kind of wants to do the multiplication first here. And it's a good thing that we know how to multiply fractions, because even though this is a fraction with a whole bunch of powers and exponents, how you multiply fractions is still the same. You multiply straight across. So we are able to combine our x terms in our numerator, and we also have some n terms in the denominator that we can combine, giving us x to the 25th in our numerator, and the 7th, and x to the 5th and the 9th in the denominator, right? So skills that you know, multiplying fractions was on the entrance exam. We talked about it earlier. It's important to know how to do that because that's what we're doing here. Essentially, just multiplying fractions, going straight across. Right? We're not done yet though, because if you ever have two of the same base, you know you can combine them some way, somehow. Okay? So where do we go from here, Alex? Okay? Okay, so 25 minus 5 is 20. Where do those 20 x's go? Are they in the numerator? Then in the numerator. 9 minus 7 is 2. Where do those n's go? Denominator. Okay? Remember, wherever you have more to start with, that's where your term is going to go. I have 2 more n's in the denominator to start with, so 2 more n's in my final answer. Okay? Questions on this? I said earlier that it didn't matter what order rules were performed in. If you started by simplifying here and simplifying here and then multiplied the fractions and then simplified further, you would still get the same result. Okay? That's the beauty of this. There's no like set order that you have to follow as long as you do everything. Ellen, you had your hand up. Right. And you got the same result? Good. Aiden. Second row, last one. So the last one. All right. Oh, I got to use my eraser here. We're going to. There we go. Be smarter than the smart board. There. All right. What would you like to do here first? Do we have all 5 rules here? Yes. We do.
How are we supposed to do that?
How fantastic. Okay.
That's the opposite of fantastic.
What do you want to do first? What do you see? Max, how do you want to start? All right. Max wants to start by eliminating the z to the 0 power. I'm not going to argue with that. Let's get that out of there. What next? Claire? Multiply the fractions? Okay. So we can multiply the fractions next, which means that our 5th power isn't going to change. We're still in parentheses here. And multiplying the fractions is going to give us n to the 9th times x to the negative 3rd up top, and x to the 7th and n cubed in the denominator. Where do we go from here? Alex, what do you want to do? Okay, and how many x's is that going to give us total in the denominator now? 10, right? Because once it moves down there, it becomes x to the positive 3rd, which when you combine it with the 7 x's we already have, actually I'm going to get rid of that for now, gives us a total of 10 x's in our denominator. Okay, let's do the n's in the same step here. How can we combine those n's, Sophie? Okay, so what's my term up in the numerator? N to the 6th. Good. I've got 6 more n's to start with. Okay. Now I can distribute, Aiden?
The exponent to the...
Yes. Yep, distribute the 5, multiplying those powers, and we've got n to the 30th up top, and x to the 50th in the denominator. Okay? Good stuff.
Bad stuff.
No, good stuff. Alex. Yeah. You will be able to calculate on the test. Tuesday. Eileen.
Nap time?
I have a question on the third one, first row.
Okay.
So I got n to the 14th times n to the negative 12.
Yeah.
So would we multiply them together or put the n to the negative 12 in a fraction?
So you've got two options here, right? She started by combining those positive powers. 5 and 9 give us a total of 14 here. We're kind of we've got two potential rules happening here, right? We're multiplying by the same base, which when you multiply by the same base, what's the rule for the powers? You add them, okay? So if we do that, 14 plus negative 12 gives us what? N squared, okay? Or if we apply the rule for negative powers, we're going to move that n to the negative 12th down, giving us n to the positive 12th in the denominator. Now we've got the rule of dividing by the same base. What do we end up with? N squared again. Okay, so it would not matter which rule you applied there. That's the beauty of it. They all kind of work together. Okay, either way, you get n squared as a final answer. Right? Good. Yeah.
So why do you have to do the end of all of them?
Yeah, these are two separate ways to get to the same end point. Jack.
Why on most of the variables is always like the last two numbers, like it's like x and n and.
Why are those letters used most commonly?
Why is it x used most commonly?
So the reason why x and y are used very commonly is because they apply to the coordinate plane. You know, you have your x-axis and the y-axis. So when we get to graphing, we'll use x and y primarily because we're going to apply it to the coordinate plane. N is used very often because kids are taught that variables represent a number, you know, n number. But really, any letter or symbol could be used, but that's kind of most common ones. Alex. Second row, second one, 2x cubed times 5x squared, okay? This one we are kind of locked into doing a rule first. Which one should we do first here? We've got multiplying by the same base. We've got the distributive property. Which one should we do first? Okay. Yeah. Distribute first. That gives us 2 cubed, x cubed, and then times 5x to the 5th. Since we've got this 2 cubed and then another coefficient of 5 here, it's probably most appropriate to write out that 2 cubed as 8 so that we can combine it with our other coefficient. So we get 8x cubed times 5x to the 5th. And then from here you can multiply by the same base. And that's where our 40x to the 8th comes from. 8. Add those powers. Multiply by the same base, add those powers. Okay? Yes, Long John. Sure. What do you want to do first here? We have options. Okay, so one option, he wants to bring that n to the negative 6th down. So we haven't touched our exponent on the outside yet. What's that going to give us in our numerator? If we remove the only term that is up there, what's left? It's a 1. Okay, and how many n's are now in the denominator of this? N to the positive 9th. Yeah, good. Okay, that positive n to the positive 6 will combine with the n cubed, give us n to the positive 9th. Now when we distribute, okay, we get 1 to the negative 2nd, which really doesn't change anything. It's still a 1. But we get n to the negative 18th. And so we end up having to move our n's back to the numerator, n to the positive 18th. And if you want to write over 1 squared, you can. But because 1 squared is just 1, if you just want to put n to the 18th, that's fine too. Okay. You could have also distributed first, and you'd get the same result, n to the 18th in the numerator. Sophie.
Because I distributed first.
Okay.
So I multiplied the 2, and so I got n to the 12, and then n to
Yeah. If you distribute first, you get n to the positive 12th over n to the negative 6th, which just means that you have to move this up anyway, still giving you n to the 18th in your numerator. So it works out either way. All right. Okay, so your homework for Monday is to finish this section here, and then the next page, which is a review of everything. You've got starting with CO10, then CO11, then 0 powers, then negative exponents, then distributive, and then everything combined. All that is due on Monday. Today is Thursday. You've got plenty of time to do it. Don't forget that Khan Academy from October 14th is due tonight. You had 2 weeks to get that finished up, and it's due tonight. Now is not the best time for questioning. We're still recording. So that's done tonight. You'll have new con tomorrow. Tomorrow will be a retake day for anyone with entrance exam things to finish up or unit 1 things to finish up. If you're all good with your objectives, new con will be assigned, ready and waiting for you. You can also save this to work on tomorrow during class. If you don't want to do it at home. Many options for that. Okay? Many options for that. Beckman. Go. Fourth row, first one. Which one is that? 14n to the negative 8th. We have several examples on this objective that you can check out. So go to CO13, take a look, and then if you still have questions, then you can ask me. The one after that, we have examples of that one too. Okay, we're to the point now where you can't ask me for help on the test as far as how to do something. So I'm going to more steer you as where you can find the answer yourself, and then if you've got further questions, then I can help you. But the independent factor is now coming along. Rowan.
Is the bottom one there an H?
Yes, that is an H. All right, that's your homework. That's all your math.
Don't forget to like and subscribe. Hit the bell. Oh, we're still recording.
We are still recording because my calibration is off.